Welcome to this short screencast on inheritance, interfaces, and abstract interclasses. So Java does not allow multiple inheritance. So this picture of class A and class B being a superclass of class C is not legal in Java. There are other languages like C++ which do support multiple inheritance. It does lead to some issues that the Java designers just decided we're not even going to address those issues. But we do want to have the ability to have some of the features of multiple inheritance, or have the idea that our subclass C does have a bunch of methods that we can describe. And so the way that Java does this is it uses interfaces to get some of the goals where we can say we know that this method exists in this class because it's not a subclass of A, but it does something. So we use interfaces to do that in Java. So an interface simply describes the set of methods that are grouped together in this interface, and that's why it's called an interface. It describes the interface. Interfaces describe the return type, the name, and the parameter list for the method, and there's no body. So it's like the way we write an interface in Java, we say public interface, we give it the name, and then we provide the modifiers, the return type, the name, and the parameter list for that particular method. And we can have multiple methods in this interface. We can define many methods, or we can define one. For example, we have a concrete interface drawable that is public interface drawable. It has one method in the interface, public void draw, and it takes a graphics of parameter of type graphics. And notice the semicolon, there is no body, there's no open curly braces. That is just saying we need to have that method draw, and the method is going to return void, and it's going to have one parameter of type graphics. So that allows us to now say that's what we have, that's the methods that we're going to have in the drawable interface. So in order to implement that interface, the class must provide all the methods defined in that interface. If it doesn't, that causes an error, so you have to fix the error. So we have public class line that implements drawable. In the class line, we need to implement the draw method that returns void and returns a graphics G. And I just noticed I had a typo in the previous slide. I have a capital D for my draw, which is now lowercase d. They have to have the same capitalization. So this class line, and we can have the rest of the line class. The way we know that line implements an interface, it must say that it implements the interface. So that's why we say public class line implements the interface. So we know that line has a draw method. And it must provide all the methods in the interface, and a class may implement multiple interfaces. So if we had a comma and then another interface name, line could implement multiple interfaces, one being drawable, one be something else, and then it would have to provide all the methods for all the interfaces that it implements. And now we have the concept that a line implements these things, so we know we can call those methods on a line. So what's the difference? This sounds a little bit like the abstract classes we were talking about last time, because we could define a public abstract class, abstract drawable, that has an abstract method draw that takes the graphics. So they're basically very similar, so you'd see they're the same. The only problem is subclasses can only extend one parent class. So since we don't have multiple inheritance, my line, if it extends abstract drawable, it still has to draw, but it can't extend any other classes. So we are still limited by our single inheritance in Java. So by using interfaces, we can now say, oh, the line is a drawable, and it is also something else if it implements another interface. And it might extend something. It might extend shape from the previous thing. So line might extend shape and implement drawable. So now it sort of has two aspects to it. It is a shape, and it also has the methods from drawable. So we can create variables with the type of drawable or the type of an interface, because we know what methods are illegal on that variable. Now we can't instantiate the interface, so we can't call new on the interface because there's no bodies, there's no instructions for how to execute those or what to do with those methods. But we can use the variable figure, which is of type drawable. We can assign it to a new line because a line implements that interface, so we know that a line is a drawable or implements the drawable, so we know what methods can be called, and then we can call those methods on this variable. Now we can't call other methods that might be in type in the line instance because we are, again, the type is drawable. That defines the methods that we can call on it. We cannot use any of the other methods in line. We can only use the ones defined in the interface because the variable is of the type interface. So that adds another way to create a Java type. We have three ways. We have it's a class, it's an interface, or it's a primitive. So a variable is either a class type, an interface type, or it's a primitive type. And if it's an interface type, if it's a class type, we can call all the methods on that class and all the methods on the parent class and in the hierarchy. If it's an interface, we can only call the methods in that interface. And if it's a primitive, we can't call any methods because primitives don't have any methods. So we can use that variable to sort of restrict the things that we know that the type is going to be of that interface, and that opens up the number of parameters we can pass in, or the instances we can pass into this. Next concept is nested classes. Basically, classes are, you can consider them the high-level building blocks of your program. So we want to build these classes that actually help solve the problem in an object-oriented way. But what do we do with these little helper classes that aren't really part of the, I mean, they're helpful in the solution, but they're not really first-class citizens in the solution. They're just sort of little helpers that maybe are very specific to another class or a part of the problem. So what do? Java allows us to have nested classes. So we could put classes inside of classes. And the first way is with a static nested class. So we have an outer class, public class wireframe model. We have a static public class line, which is inside the wireframe model. And it basically defines a three-dimensional line. It has 2 points in X, Y, and Z, and that's your line. So what we've done is, because it's public and it's static, we can refer to the line as wireframe model.line. If we're inside the class wireframe model, anywhere else in the class, we can create a line by just using line equals new line. That is because we know we're inside our wireframe model class, so we confer it. And because the inner class is public, we can refer it to the outside world by saying wireframe model line equals new wireframe model line. So we can create these lines outside of the class because it's public and static. We use the class name and then the class name because it's static. We can also have non-static inner classes that are associated with the instance of the class. Remember how we have instance variables, we have instance methods, we now have instance classes. So in the public class poker game, we have an inner class player, and it's referring to players for this particular poker game instance. So it's usable inside the class, just like any other class inside. You can create new players inside the poker game. You can do all the things, you can manipulate it. Now, if you're outside the class, you don't say poker game dot new player, because you can't do that because the name of the class is not poker game, it's not static. You need to create an instance and then you can create a player by using the new operator. I see how it's g.new, and then player, that's the inner class inside the instance G. Not used a lot outside the class. In fact, most of the time your inner classes are private so that they are only useful in the class itself, but if it's not private, it can be accessed outside the class. The issue is it's very difficult to be able to create variables of that type. But it is accessible outside the class unless you make that player class private. But it is, if you make it private, it's helpful perhaps in your implementation of a poker game, and if it's private, the outside world doesn't need to know about it, and that's why you can hide these helper classes inside your big solution classes. Now, we can also have anonymous inner classes. Before, we talked about how we cannot construct an object from an interface. So drawable's an interface. The variable figure is of type drawable. We cannot say new drawable. That's illegal. You cannot instantiate an interface. But Java does allow for anonymous inner classes. So if we wanted to create a class that implements drawable, that sets the draw to red and makes a red rectangle, we could create a inner class, but Java allows us to do that with the new operator to create an anonymous, non-named class where we use the new operator, the interface, any parameters in the interface or constructor, if you're going to do a superclass, open curly brace, and then the implementation of the methods for the interface. So drawable had one method, draw. If we implement it, we're creating a new class. We're actually creating, and it's not named, it's anonymous, not named, and we're actually creating an instance of that new class, and then we're assigning it to the variable figure. This is helpful for creating one-time instances. It's often very helpful for passing into methods that require a variable of type of some interface or of some class. We can actually instantiate a new one on the fly with very specific behaviors because we have to implement all the methods in that interface. Don't worry too much about it. I don't think we're going to get much. I just want to talk about that briefly. It's very powerful later on for solving problems, but that's a little more advanced than we'll talk about in ICS 111. So I just wanted to introduce it. It is a concept. It's very powerful, but don't really worry about it if it's a little confusing how you could create a new instance of a class that has no name because there's no class here, but we actually implement. We have the bodies for all the methods in that interface, but it's a very powerful thing that you'll see later on in further Java courses or when you're programming in Java. Thank you very much.